192.168.210. And after that, in the, for example, PC2, this is the PC2. Let me to show you the ARP-A. Here we have 192.168.2.1 and the MAC address of this, for example, IP address. And because of that, now the R2 has enough information for sending the traffic inside of this network. Because of that, now the R2 can forward the traffic after decrementing the TTL with one value. For example, this traffic now can be forwarded with the TTL of 126. The source IP and destination IP should not change, but the source MAC now is the MAC address of the interface of router. This is the MAC address of the interface of router, source MAC. And then we have destination MAC. Destination MAC is MAC address of the PC2. This is the MAC address of the PC2. Okay. And after that, now we can send this traffic inside of this network. Here in the capture, we can see this ICMP echo request. 192.168.110 is the source IP, 192.168.210 is the destination IP, and then the source MAC is the MAC address of the interface of router, as you can see, and destination MAC is the MAC address of the PC2. Also about the TTL, if you want, in the IP header, you can verify the TTL is 126. This is the process for sending ICMP echo request. For receiving the ICMP echo reply, we have a simpler process. Why? Because we have learned about the MAC addresses. Let me to explain it. Look at here. We are receiving the ICMP echo reply from the PC2 to the PC1. Okay, why? Because when we are sending ICMP type 8, we expect to receive ICMP type 0, means echo reply. Okay, and this is one of the rules of the TCP IP. The TTL default value as TTL maybe is 128. This is related to the operating system. The source IP now is 192.168.210. Destination is 192.168.110 in reverse order. But you know that first the PC1 should route the packet, and because that the destination IP and source IP does not equal about the first 24 bits, they are residing in different networks, and the PC2 understand that the traffic should be sent to the router 2. The source MAC is the MAC of PC2. Okay, this is the MAC address of the PC2, and the destination MAC is the MAC address of the router 1. You know that the PC2 now know the router 2's MAC address. The PC2 now knows about this MAC address because in the previous part, in the ARP process, in the ARP cache or ARP table of PC2, you saw that we have this MAC address. Okay, after that, this is the MAC of the PC2. This is the MAC of interface of router. We are sending this traffic. The router is receiving this ICMP echo reply because the destination MAC is pointing to the ETH00. The router should accept it. After that, the packet now is available. Again, you know that the packet should be compared with the routing table of the router 2. This is the router 2 routing table. Okay, the destination IP is pointing to the 192.168.210. You know that we have configured one static route for this network, show IP route. 192.168.10/24 can be reached from the serial 10 with the 10.0.0.1 as the for example next hop, because here we are using the HDLC. Actually, we don't need to send ARP requests or learn for example some MAC address, because here we are using the point-to-point interface, and in the point-to-point interface we don't have the concept of MAC address. And after that, in the step 11, the ICMP echo reply can be sent over the serial 10 after adding the HDLC header. Where the ICMP echo reply, TTL should be decremented to 127. The source IP is 192.168.210. Destination IP is 192.168.110. And also here we have HDLC header. That's it. This packet, this frame can be received by the router 1. Router 1 should de-encapsulate the for example HDLC header, and now this packet is available for routing in the router 1. The router 1 again should compare it with its routing table, router 1 routing table. Okay, and you know that this network connected to the interface of router 1. Look at here in the R1, in the show IP route, you can see about the 192.168.10/24 we have a directly connected networks. Because this is the Ethernet networks, we need the MAC address of the destination IP, but we have the MAC address from the previous ARP process. And after that, the router 1 easily can use this ICMP echo reply, but after decrementing the TTL, we need to add one, for example, Ethernet header and also Ethernet trailer. The source MAC in the Ethernet header is the MAC of interface of router. This is the MAC of interface of router. And after that, the destination MAC is the MAC of the PC1 that the router 1 before learned it. And here, this is the MAC of the PC1. And this packet can be forwarded to the PC1. Finally, the PC1 is receiving this ARP reply. Here you can see the process. This is the capture of link between the PC2 and the router 2 for ICMP ARP, the ICMP echo reply, as you can see. Okay, echo ICMP type 0, code 0, type 0. The source IP is 192.168.210. The IP of PC2, destination IP is 192.168.110. And after that, here, as you can see, the source MAC is the MAC of PC2, destination MAC is the MAC of router 2's Ethernet 00 interface. Then this traffic should be forwarded to the router 1, and after that, router 1 should forward the traffic to the PC1 without the ARP. Here you can see 192.168. For example, first, this is ICMP echo reply, okay, type 0, code 0. Source IP is 192.168.20, and destination IP is 192.168.1. For example, 10. You know that the source IP is 192.168.210, the IP of PC2. Destination IP is the IP of PC1. This means that the source IP and destination IP should not change in all over the pass. But the source MAC is MAC of the interface of router, and destination MAC is the MAC of PC1. This means that the layer 2 header about the addressing now is changing over the pass. Okay, and finally the PC1 now is receiving this packet. This is the packet forwarding process. As you saw in this process, we are using multiple tables. Okay, in this process I didn't talk about the MAC address table because MAC address table is related to the layer 2 forwarding. I am talking about the packet forwarding process, means layer 3 forwarding. But if you want, you can analyze also the layer 2 forwarding or MAC address table content in the switch 1, switch 2. Okay, but here let me to say that about the ARP table, this is a table that inside of it we have the layer 3 address, okay, to layer 2 binding, layer 3 to layer 2 binding. Okay, for example, or translation. Okay, for example, in the Ethernet we need the IP to MAC binding, but let me to say that in another environment, this is for Ethernet, in other multi-access technologies we are using other binding. For example, in the frame relay, one of the Ethernet WAN, for example, one of the WAN switching networks, okay, we are using another physical address. We call it the DLCI, or data link connection identifier. In those networks we are using the IP binding to the DLCI, or data link connection identifier, or also in DMVPN we are using another term of for example layer 3 to other layer binding. Okay, because of that, the first table is the ARP table. In most cases in the Ethernet we are using Ethernet, and in Ethernet we are using the IP to MAC binding. It is so easy. Also, we have used the routing table. Routing table is one of the most important table that today's we are using for sending traffic from one place to other place. Okay, and you know that the routing table is residing in each router. I will talk about more than this about the routing table, but for now let me to say that if you want to verify the routing table, you can check the show IP route. Okay, also here we have some important notation. Let me to talk about them because maybe this information is useful for the troubleshooting. But before talking about the routing table and the show IP route, let me to say that in one router with the show IP ARP, you can verify the content of ARP table. Before talking about the routing table, maybe you ask me, what is the need to learning about the packet forwarding process? Why we should learn the packet forwarding process? Look at here. Assume that here in this network we have a PC1 connected to one switch. Okay, and this is connected to router 1. Here we have one serial link between the router 1 and router 2. Again, another switch, again
Assume that here we have for example, one server. Assume that this is a web server, and one person, one user is working on PC1, and now you are receiving a troubleshooting ticket about